Welcome back to StackTrekker. In this video, we'll dive into search in Elasticsearch, the core feature that makes it so powerful. We'll start with the basics like match, term, and multi-match queries. Then we'll look at ways to customize results with pagination, sorting, boosting, and highlighting. Finally, we'll apply everything to a movies dataset, running searches by title, director, and actors, and experimenting with filters, phrases, and fuzzy search. All right, let's get started. I assume you already have Elasticsearch installed and running. If not, don't worry. Check out my channel where I have a full playlist that walks you through installing, configuring, and using both Elasticsearch and Kibana. You'll find the link to the first video on screen right now and also in the video description below. All right, let's prepare some data for our tests. The first step is to create a mapping. A mapping is basically the description of our data. It tells Elasticsearch what fields exist, what type of values they hold, and how Elasticsearch should handle them during indexing and search. To upload the mapping, we'll make an HTTP request to our Elasticsearch server using Postman. If you installed Elasticsearch on the same computer, you can simply use localhost. In my case, I'll specify the IP address of another machine where Elasticsearch is running. We also need to give our index a name. Since we'll be working with movie data, let's call the index movies. The request type should be set to put because we're creating a new index and defining its mapping. If your Elasticsearch requires authentication, just provide the credentials. If you didn't change the default password, you can use that. Otherwise, enter your own username and password. Now download the file with the movie's description. You'll find the link on screen and in the video description below. This file contains an array of movie objects with fields like title, year, genre, director, and more. Open the file, copy the JSON content, and paste it into the request body in Postman. When everything is ready, press the Send button. If everything is correct, Elasticsearch will respond with an acknowledgement and the mapping will be uploaded successfully. Okay, after creating the mapping, we also need to provide the actual movies data. For that, we'll use the same movies URL as before, but this time we'll add the bulk path at the end. The request type will be changed to post because now we're sending data instead of creating the index. The authentication works the same way as before. If your Elasticsearch requires a username and password, just enter them here again. Next, download the data file. The link is on your screen right now and also in the video description below. Since the number of movies can be very large, we won't copy-paste everything into Postman manually. Instead, we'll use File Upload. Select the file you've just downloaded and attach it to the request body. If you open this file, you'll notice that it contains many movies, and each entry follows the structure we defined earlier in the mapping file. Fields like title, year, director, and other. Once everything is set up, click the Send button in Postman. Elasticsearch will start processing the bulk request and insert the movie data into the index. If everything goes well, you won't see any errors. Instead, Elasticsearch will respond with some technical information about how the data was stored. This means our movies have been successfully imported and we're ready to run some searches against them. To start a search, simply copy the URL you used earlier and append search to it. For the search request, use the GET method. Don't forget to include authentication credentials if your cluster requires them. Let's start with full-text queries, the core Elasticsearch searches for natural language text. Let's begin with match, the simplest and most common full-text query. The match query analyzes both the field content and the search term, making it ideal for natural language text. This tells Elasticsearch to look for documents where the title field contains the word Godfather. After executing the request, you should see two matching movies because both titles include the word Godfather. This query searches for that exact word, so if you change it to something that doesn't exist, you'll get no results. Fortunately, you can allow typos and still get matches by adding the fuzziness parameter to the match query. Even if the word is misspelled, Elasticsearch will still find The Godfather. After running this, you should still see the same 2 Godfather movies, even though the title is misspelled. Next, let's look at multi-match, which lets you search multiple fields at the same time with a single query. This is especially useful when your data contains several text fields like title, director, and actors, and you want to find documents where the search term appears in any of them. In this query the text we're searching for, in this case Christopher Nolan. Fields, the list of fields to search across. Elasticsearch analyzes the phrase and searches each specified field. Next, let's look at match phrase, which is used when you need to find documents that contain an exact sequence of words in the specified order. Unlike a simple match query, which can match any combination of the words, match phrase ensures the entire phrase appears exactly as provided. Match phrase treats the search text as a single phrase, so the words must appear together and in the same order. We use title.keyword instead of title to target the keyword subfield, which stores the exact unanalyzed value of the title. If we used title, a text field, Elasticsearch would tokenize the value into separate words, and the query would behave more like a regular match unless we added extra settings. When you run this query, Elasticsearch returns only the documents whose title field matches the phrase exactly, in this case, the movie The Godfather itself. It will not match titles like The Godfather Part 2 or Godfather Returns, because those contain additional words. Let's move on to numeric and date range queries. These are perfect when you need to filter results based on numbers or time periods, like years, ratings, or release dates, rather than searching free-form text. Sometimes you want to narrow results using more than one numeric field at the same time. For example, suppose you'd like to find movies released in the year 2000 or later, and with an IMDb rating of at least 8.8. We can combine these 2 conditions with a Bool filter and 2 range clauses, each using GTE, which means greater than or equal to. When you run this query, Elasticsearch returns only the high-rated movies released from 2000 onward. Perfect if you want to highlight modern classics or create a best of the 21st century list. Now let's look at a date range. Imagine you want to see every film released between 1990 and 1999. Here we still use the range query, but provide ISO formatted dates and specify both a start and an end using GTE and LTE. This returns all movies with a release date inside that decade, which is ideal for decade-based reports or dashboards. You can see that Elasticsearch reports 44 total movies found, but when you scroll through the response, you notice far fewer documents are actually listed. Why is that? By default, Elasticsearch only returns the first 10 matching documents in the hits array. That's just a safeguard to keep responses small and fast. If you want to view more, you need to explicitly increase the number of results by adding a size parameter. Now you can compare the output and see that more movies are included in the response. And to answer the unasked question, Elasticsearch doesn't have a Give Me All Documents flag. Allowing a single request to dump an entire large index could overload the cluster. Also, one point about displaying the result. By default, every search response shows the entire document with all its fields. Sometimes that's not practical. You might only need a few key fields. Elasticsearch lets you control exactly what is returned, and you can specify the fields to include or exclude. Here we want to see only the fields title and year. If we want to see all fields except title, you can do the following. Let's continue with Boolean queries. In Elasticsearch, a Bool query is a container that lets you combine multiple smaller queries in flexible ways. It supports 4 main clauses: must, all these conditions must match, and they contribute to the relevance score; Filter, conditions that must match but don't affect the score and are fully cacheable for speed. Should, optional clauses. The more that match, the higher the score. Must not, documents matching these are excluded. Think of it as building blocks. You can mix these clauses to express almost any combination of and, or, and not logic while maintaining control over scoring and performance. Now let's look at a practical example of a Bool query in action. Here we're searching for movies that meet several conditions at once. Must, the director must be Christopher Nolan. Filter, the genre must be either action or sci-fi, and the year must be between 2010 and 2014, inclusive. We also limit the fields returned with source, so we only get title, year, director, genre, and IMDb rating. Finally, we sort the results first by the relevance score and then by IMDb rating in descending order. Now let's check the results and confirm the sorting order. The matching movies should be listed by their IMDb rating in descending order, so the highest rated titles appear first. Let's move on to another example that introduces the should clause with a minimum should match setting. This query targets Star Wars era films released between 1980 and 1983 and remains flexible about which conditions are met. Should, we check for actors Mark Hamill, Harrison Ford, or Carrie Fisher, and also for directors George Lucas, Irvin Kershner, or Richard Marquand. Minimum should match twos. At least two of these should conditions must match for a document to be included. Filter limits the year to between 1980 and 1983. Source, we only return title, year, director, and actors fields. Running this query will return only the movies released between 1980 and 1983 that match at least two of the listed actor or director conditions. Here's a more complex Bool query that combines multiple nested conditions using should with inner Bool filters. It returns highly rated movies that meet at least one of two distinct scenarios. First branch, sci-fi or action films released from 2000 onward with an IMDb rating of at least 8.6. Second branch, movies directed by Alfred Hitchcock or Stanley Kubrick released in or before 1980 with an IMDb rating of at least 8.3. Minimum should match 1 means a document only needs to satisfy one of these branches to be included. The response includes title, year, director, genre, and IMDb rating, sorted first by highest rating and then by most recent year. After executing the query, you'll notice a mix of new releases and vintage classics because some older films also satisfy the second branch of the conditions. This demonstrates how a single Bool query can seamlessly combine different time periods and criteria, allowing Elasticsearch to return both modern blockbusters and timeless masterpieces in one unified result set. So, that's it for today. In this tutorial, we covered the essentials of Elasticsearch Search, from simple full-text queries to advanced Bool filters and custom sorting. So I hope this was interesting. Thank you for watching my tutorials. If you enjoyed this, please like the video and subscribe. See you later. Bye.